Good morning students, welcome you all for online classes. Today we will discuss the topic on CPU and primary memory. In previous classes we have discussed about computer generations, computer types, bits, bytes and words. Okay, today we will discuss what you mean by CPU and primary memory. See, inside the computer, here this we can call hard drive, and this one is called CD or DVD. Okay, and these we can call power cord. Here we are getting chip, and this one is pan, and this we can call SMPS, that is power supply. Okay, to cool the CPU we need pan, then video cards, modem and sound cards. So this we can call case. Okay, here we can these cables are bus, and these all are power cables. Okay, and this is what the structure of computer. Now in a diagram, here are two parts, one is CPU and primary memory. Okay, and another one is input output controller. Inside the CPU we will get ALU, then control unit and registers. In primary memory there are two types of memories, that is random access memory and read only memory. And in case input output controller means it will accept the input and produce the output. So here secondary memory is responsible, and in secondary memory, that is hard disk, then DVD ROM drive, tape drive, then flash memory. Okay, in another part is mouse, keyboard. These all are input device, monitor, printer. These all are output device. Then scanner is input or output. Scanner is input device. Then this part is related to network. Okay, it may be wired or wireless, then Bluetooth. So this is what architecture of a computer with single processor. Now this is called motherboard. In this motherboard, this is called CPU socket. This is called what? CPU socket. These all are connections, connector ports. Then these all are expansion slots. If you want to increase the RAM size, you can put the RAM slot. And this is called memory slots. Then these slot we can call storage drive. We can connect here secondary devices or secondary storage devices we can connect. Now we will discuss this part, CPU socket. Okay, here we can put the CPU, central processing unit. Okay, let's see. This is what CPU. In previous diagram we have seen only socket, but here CPU is there. Okay, what do you mean by CPU? CPU is central processing unit. It's a chip, so we can call it as CPU. Now, this is diagram of CPU. Inside the CPU we have three parts. One is memory unit, another one is control unit, then ALU unit, arithmetic and logic unit. Okay, we'll discuss these three parts inside the CPU. CPU is considered as the brain of a computer. Then it performs all types of data processing operations. Data processing operations means data, it can receive data, it can transfer, okay, process the operations as per the requirements, and it stores the data, intermediate results and instructions. Here data means what? Data means it may be file, it may be audio file, or it may be video, it may be image, that we can call data. Okay, and intermediate results and instructions. Instructions means what we are performing. Okay, based on that task we can call instructions, and it controls the operation of all the parts of the computer. It has the capacity to control input device, then output device. Overall, all parts should be controlled by CPU, and it has three components. One is memory unit, or we can call storage unit, this unit. Okay, and control unit, this part, then ALU, that is arithmetic and logical unit. Okay, let's see what we mean by memory unit. Memory or storage unit, it can store data, because we are talking about memory, right? So memory, it performs what? Storage. It can store data, and it supplies information to other units of the computer. Supplies information to other units. Other units means what? Here control unit, arithmetic logical unit, or output unit, or input unit. Okay, because if we place the data in our computer, okay, this data we can, it is responsible for input device, it is responsible for output device, right? So it supplies the information to other units of the computer, and it is also known as primary memory or random access memory. This part we can call primary memory or RAM, random access memory, and its size affects speed, power and capability. Nowadays RAM size is 8 GB. Okay, in before we are using 1 GB RAM, then 4 GB RAM, and even 512 MB RAM we are also there. So this based on this RAM capacity, it affects your performance of computer speed, then its capacity. There are two types of memory in computer, that is primary memory and secondary memory. We'll discuss it later. Okay, in memory unit, it has two parts, that is primary and secondary memory. Then its function, it stores all the data and instructions required for the processing, and all inputs and outputs are transmitted through the main memory. See, this one is input part and this one is output part. This one is calculation monitor. Okay, this we can call input device, and this we can call output device. Okay, this we can see CPU. all inputs and outputs are transmitted through the main memory. If you supply the any input data, it will first go to RAM, then it process the data, then it produce the result into output device. From this device you can see the data. Okay, its main function is what? Memory will hold the data. See, in this figure, this is what we can call CPU chip. Here all the informations coming from all the devices, right? And it will going to store all the data, okay, to perform the particular task. Now control unit. It controls the, now we are talking about this part, okay. It controls the operations of all the parts of the computer. That's what we can say control unit. Controls all the operations. It may be calculation operation, it may be input operation, or it may be output operations. So it will perform all kinds of operations in this unit. It is responsible for controlling the transfer of data and instructions among other units of a computer. So transfer of data from one unit to another unit, okay, and instructions among other units of the computer. It manages and coordinates all the units of the computer. All the units. It will act as a team leader. Okay, control unit. It obtains the instructions from the memory, interrupts them, and directs the operation of the computer. So what kind of operation? For example, if you supply the calculation part 2 plus 3, okay, result is what? 5. So to perform this operation, first data will go to where? Memory unit. Then memory unit you are performing what? Plus addition operation, right? To perform this addition operation, it will go to where? Logical unit, to make the operations, logical operations. So after making this, it will give the result, right? So with the help of this result, 5 will going to store on your register, then it produce the output as 5. So it obtains the instructions from the memory and interprets them and directs the operation of the computer, and it communicates with input and output devices for transfer of data or results from the storage. Here it communicates with input and output device. This is input device and this one is output device. Okay, assume transfer of data or results from the storage. Transfer of data means just now we have performed 2 plus 3. Okay, 2 plus 3, it will first go to memory unit, then perform the arithmetic logical unit, that is addition. Here result will going to what? 5. After giving this result, it has to store the result on memory, right? After storing, it has to display the output, right? To display the output, it should go to where? Output device. In that output device we are getting result is 5. So this is what about control unit. I hope you understood this concept. Next part, arithmetic logical unit. Here This unit consists of two subsections, namely arithmetic and logic section. So combined to these two sections you can call arithmetic logic unit. So here see in this figure, this we can call ALU registers, then carry, then this is ALU unit, this part. In this part two sections, one is arithmetic, another one is logic section. So what do you mean by arithmetic section? It is to perform arithmetic operations. Arithmetic operations means what? Addition, subtraction, multiplication and division. All complex operations are done by making repetitive use of the above operations. So complex operation means plus, minus, star, then plus. Okay, so big problems or big operations should be done by making repetitive use of the plus, minus, star, division operations. Okay, then logical section. In logic section it is to perform logic operations. So what kind of logic operations? Comparing, selecting, matching and merging of data. These we can call logic operations. Okay, very simple concept. Arithmetic operations are addition, subtraction, multiplication. Then logical operations are comparing, selecting, matching and merging of data. If your data is like this, 2 plus 3, so which operation will perform here? Arithmetic operation will perform, right? If your data is whether 2 less than 3, 2 greater than 3, 2 less than 3, in this situation what will happen? The movement will go to logical section. Okay, or whether you perform 2 equal to 2, condition true or false, like that. Okay, whatever it is there, maybe it may be comparing, selecting, matching and merging of data. So what do you mean by merging here? Merging of data. See, in one section, okay, in one part hi is there, so okay, another part is welcome. Welcome, this is part number 2, this one is part number 1. I want to merge this sentence. Okay, so how after merging this, what will get? It we can call concatenation. Okay, here the result is what? Hi, welcome, right? So this is called merging. So arithmetic and logical sections belongs to ALU, that is arithmetic logic unit. Now memory, we are talking about memory, that is primary memory. Okay, so memory is just like a human brain. Yes, in your brain you can remember all the activities, right? So same way memory is just like a human brain, and it is used to store data. Data means what here? It is used to store data, computer data. Data will represent in which way? Only 0 and 1. This is computer data. If you have image file, so it should be represented in terms of 0 and 1. If you have video file, its data is what? 0 and 1. So this we can call data. It is used to store this data. So we are talking about computer memory. This is computer memory. Okay, this data is going to store on memory. Then another one is instructions. Instructions means what you are performing, what you are giving. If you give 2 plus 3, right? Instructions is what here? You are addition of two numbers. This is called what? Instructions, right? Computer memory is the storage space in the computer where data is to be processed and instructions are required for processing or stored. So instruction is also required for processing or stored. Okay, this is about memory. In this memory we have two types. One is primary memory, another one is secondary memory. In primary memory, again we have to divide RAM and ROM. In secondary memory comes under floppy disk, hard disk, CD, DVD and pen drive. Okay, these all are comes under secondary memory, means external storage devices, and internal storage devices are RAM and ROM. So internal storage device we can call primary memory, then external device we can call secondary memory. So now we will discuss in primary memory. Primary memory is the main memory of the computer system, right? Accessing a data from primary memory is faster because it is an internal memory of the computer. See, in computer that I will show you in next slide. So how this memory will work. Okay, but right now you just remember it is main memory, primary memory you can call main memory, and accessing the data from primary memory is faster because it is an internal memory of the computer. For example, this is your CPU tray. Here this is hard disk, or you can call secondary memory, and this one is what? Main memory, and this is called your CPU. Okay, here every data should go to CPU. It may be primary memory or it may be secondary memory. Okay, now we are talking about primary memory. This is what? Primary memory. If our data is here, then to access this data it should always go to CPU. So this is what we can call access the data from primary memory is faster because data is here only. So CPU is going to catch this data easily. If your data is in secondary memory, this is called your secondary memory. Okay, this secondary memory, first it will go to main memory, then main memory to CPU, then CPU to secondary memory. So it will take little bit time, right? That we will discuss in secondary memory. Now in primary memory again two parts are there, that is RAM and ROM. So in RAM, SRAM and DRAM is there. SRAM means static random access memory, DRAM means dynamic random access memory. Then ROM, read only memory, contains three parts: EROM, EEPROM and EEPROM. Okay, we will discuss these memories. Now first we will discuss random access memory. So how this random access memory will work? Suppose this one is your secondary disk, this is your RAM, or you can call main memory, this is CPU. Here what will happen, data will go to first random access memory only, not directly CPU. It will first go to random access memory. After moving your data to random access memory, then it is accessible for CPU, CR. That's why primary memory is fast compared to secondary memory. This is your secondary memory, then this is your primary memory, that is called RAM. Okay, RAM size is maybe 1 GB. You know very well about GB, right? Gigabyte. Then it may be 4 GB minimum size. Nowadays RAM size is 8 GB, and before their memory size was 5112 MB. Now it is updated to 1 GB or 4 GB and 8 GB compared to price. Okay. Now this RAM, once the operating system is loaded, the computer uses the RAM, which stands for random access memory, which temporarily stores data. Repeat, temporarily stores data while the CPU is executing other task. After executing the task, this memory will going to erase. Then RAM is fast, but it is volatile. Volatile means what? Please remember this keyword, volatile and non-volatile. Volatile means it will not retain a data if there is no power. If power is off, then your data will going to erase. So that's what we can call RAM is volatile. That's it. It is therefore important to save the data to the storage device before the system is turned off. Storage device, we have to store our data before power upping the system. That's what we can call primary memory is what? Volatile, or RAM is volatile. When power is off, the entire data will going to erase. Types of RAM. There are two types of RAM. One is dynamic random access memory, then another one is static. In this RAM, it stores a bit data using pair of transistor and capacitor. Transistor and capacitor, have you heard these words in generations, right? Okay, bit is what bit data means, what kind of it is? It may be 0 and 1, two values only, right? 0 and 1, using a pair of transistor and capacitor which constitute DRAM memory cell. So this is called what? DRAM. Here your data will going to store in the form of 0 and 1 using pair of transistor and capacitors are there. Here in this chip, transistors and capacitors are there, and it has to be refreshed every few milliseconds to retain the data. Every milliseconds it has to updating or refreshing. Whatever new data is coming, take that data, then after performing the particular task it has to erase, then take the another data. Okay, then every milliseconds it will going to refresh, then to retain the data. This is called DRAM. Now another one is static RAM. This is called static RAM. Here it stores a bit data using the state of 6 transistor memory cell. Here 6 transistor memory cells are there, and it is faster than DRAM but costlier. It is fast and it is also costlier compared to your DRAM. Here 6 transistor memory cell. These we can call 6 transistor memory cell. 1, 2, 3, 4, 5 and 6. Inside this 6 transistor memory cell. Okay, I hope you understood this concept. Static random access memory. I am showing everything regarding these concepts. Then we move on to read only memory. In RAM, 2 types of RAM. One is static RAM, then another one is dynamic. But in another part, read only memory, here is a type of storage medium that permanently stores. RAM is temporary, but read only memory, it permanently stores data on personal computers and other electronic device. It contains the programming needed to start PC, which is essential for boot up. Boot up means what here? Boot up means when you are going to switch on your computer. Yes, this is button, right? And this one is memory, this one is monitor, and this one is keyboard. Okay, when you switch on your computer will start. This is called what? Boot up process. Inside the computer, what will happen? Same way I have shown the figure, right? This is CPU primary, and then this one is CPU. This is your hard disk. Okay, this is RAM, this is CPU. So when you power on your computer, what will happen? Your OS will load onto RAM, then this RAM will going to make the system will start. Okay, so this process we can call boot up process. Now it performs a major input and output task and holds the program or software instructions. Because it will going to store permanently, then it performs the input output task and holds the programs or software instructions. And in RAM, 3 types. One is PROM, EPROM and EEPROM. So what kind of these PROM? Let's see. This is read only memory chip. Okay, programmable read-only memory. This part we will going to learn in detail in analog and digital subject. Okay, programmable read-only memory. It can be programmed by user because the concept is what? Programmable. Once the programmed, the data and instructions in it cannot be changed. Here programmed by user, but after programming the data and instructions will not going to change. It is fixed. So that's what we can call programmable read-only memory. Okay. Then another one is EEPROM. Here erasable programmable read-only memory. Here it can be reprogrammed, but to erase a data from it and expose it to ultraviolet light. Here ultraviolet light, to reprogram it and erase all the previous data. PROM, it is read-only memory, but here EEPROM means erasable. We can erase the program and we can reprogram it. Okay, this is called EEPROM. Reprogram, erase the data, and to reprogram it, erase all the previous data. Simple concept. This is EEPROM. And another one is EEPROM. Here electrically erasable programmable read-only memory. Electrically we can erase the programmable. The data can be erased by applying electric field. No need of ultraviolet light. In EEPROM we are using ultraviolet light, but here no need to use ultraviolet light. Only we are applying electric field. We can erase only portions of the chip. Here this is called what? Chip. We can erase the portions of the chip. Okay, these are kinds of ROM. And now let's see difference between RAM and ROM. RAM is temporary storage, but ROM is permanent storage. By the definition we can differentiate. And store it data in MB, that is RAM, then store data in GB. Your hard disk, right? Then RAM is volatile. It is non-volatile. Volatile means when power is off, your data will going to erase. But here after saving, when your power is off but data is available, so that's what we can call it is non-volatile. Used in normal operations, used for startup process of the computer. To booting up the process, it needs what? ROM. Writing data is faster here in RAM, then writing data is slower in read-only memory. So these all are the difference between RAM and ROM. And now these are difference between what types of ROMs? Read-only memory. That is PROM, EEPROM, then EEPROM. Read-only memory that can be modified only once by a user. Means once we have a program, it is fixed. It will not going to change. EEPROM, programmable ROM that can be erased and reused. You can reuse the data. User modified ROM that can be erased and reprogrammed repeatedly through a normal electrical voltage. Here ultraviolet rays is needed, but here electrical voltage. We can reuse it. This stands for what? Programmable read-only memory. Here we can also differentiate between this expansion of this EEPROM, erasable programmable read-only memory. This is electrically erasable programmable read-only memory and developed by Wen Xing Chow. This is developed by Doe, then developed by George. Programmable only once, can be reprogrammed using ultraviolet light, can be reprogrammed using electrical charge. These are the simple difference between PROM, EEPROM and EEPROM. Okay. If you have any doubts regarding these concepts, please ask me. Okay. Thank you.